I wanted to welcome you. This is Andy Zaski, VP of Sales and Marketing at Tolomatic. We're continuing our series here. This is week 7 or 8, maybe. We've done approximately 30 ToloTalks over the last 8 weeks, and those are all posted online at our website. If you go to the website page, you scroll down, and on the far right-hand corner, there's a ToloTalks link. Every single ToloTalk we've done over that time period is posted there and recorded. So feel free to use that to further your knowledge. Feel free to use that with customers. I also have an ask as we go forward here. We're trying to shift our focus a little bit on ToloTalks to be more personal. So I would like to invite you to invite us to present for 30 to 45 minutes at your distributorship with your distributor sales team at a time of your choosing, where we could come in, present any one of the presentations we've done or some sort of hybrid, and then talk through your team in your group so that it's more interactive and collaborative. That's one ask. The other request I have is get with your sales leaders and marketing leaders to see if there are ways we could do this sort of training material for some of your customers, either a broad base of them, sort of like this, so a webinar series, or even a very targeted presentation to a specific customer. So all of these are available to all of my salespeople and my application engineers. They all have access to every single PowerPoint. All of the recordings are there, and we could mix and match and do something custom for you. So that's my request of you as we get going here. But to start off today, we've invited a partner of ours named Solve to co-present with us here. So Luke, I appreciate you being on today, and welcome to ToloTalks.
Thank you, Andy. Good morning, everyone.
Great. So we're going to start today, and we're going to talk through something we haven't spent a lot of time on, but this really builds off of one of our core competencies, which has been rodless linear actuators. And in this case, we're focusing on the electric side of things here, both belt-driven and screw-driven. And as you can see, we're talking about gantries and multi-axis applications. So it encompasses all of our products. The basis of this design, a multi-axis and gantry system, would typically be the rodless actuators you see at the bottom of the page here. You can see our B3 series on the far left. We have our wraparound carriage. We have our straight carriage here. We've got belt drives, screw drives, our MX product here, some with a THK profiled rail on the side, others with a solid bearings carrier here, some without any bearings, so you have a rail guided system. And then many times these multi-axis systems also include some sort of rod style actuator. So you'll have your X and your Y, and then perhaps your Z axis is here in a rod actuator. So we'll talk about the combination of all of these. Tolomatic is a little bit uniquely situated. We've got a very broad portfolio. There's a lot of tools in the toolbox and a lot of ways that you can connect with us and create solutions for customers that need gantry and multi-axis systems, especially systems that are a little bit larger. We have several competitors that are, IAI and other folks that have pre-engineered 3-axis systems, smaller pick-and-place type actuation systems. We're thinking a little bit bigger than that, and our experience and our success has really been on larger scale multi-axis systems, typically moving heavier things, moving larger pieces, moving stuff around larger pieces. So, and you'll see that as we go through the presentation here. So there are some things that Tolomatic typically has not done well, and things that we've leaned on either our distributors, or in this case, we're looking to lean on Solve as a partner. And you might have other partners in your territory that you'll be working with as well, system integrators. Some customers can handle this sort of work on their own. Others would like someone to do that for them. We're just going to educate you on all the various pieces of the things you need to think about, the things you can help your customer think about, and then you can decide on best how to do that with your customer. But as you can read down here, there's a lot of things around cable tracks, transition plates, jack shafting, and then putting all those various pieces together. So those are all the pieces that typically, Tolomatic hasn't had solutions for, and we have looked to you and your system integrators to do. But that builds it starts with this actuator solution here, and then the bits and pieces that make that possible and integrate those into a solution. The questions to ask on this conceptual design, if you're sitting down with a customer, you want to talk through, what's your budget for this? What does that look like? what are your expectations on payload and those cycle times, speeds, et cetera, that you need. How much room have you got to work with? What kind of interpolated motion are you potentially going to have? And that accuracy and repeatability, this is a key piece here. How accurate and repeatable are you going to be? And we've even seen multi-axis systems work collaboratively with robots, and we've actually seen some of them move robots inside of those areas. So be thinking about that as well as we think more and more about automation in the current economy, and as we drive forward with more and more manufacturing and reshoring of jobs and capabilities here in North America. There are belt and screw combinations here that are available. And then depending on what environment you've got, we may suggest different types of Tolomatic actuators. Some have very tight sealing capability to keep out material, and then others are fairly open design. So if you're in a more clean environment. This just gives you an idea. And then of course, you always have to think through, what's the control architecture going to look like? What kind of motor and drive solutions or gearboxes are going to be put on this? And we offer a broad array of capabilities around your motor here to do that. So you sat down with your customer, you've talked about what they want to do, what their end goal is, what the requirements are from a precision standpoint, a quality standpoint. And then you can sit down with our Tolomatic regional sales manager, our applications engineers, and in this case with Solve. So we map out what are the Tolomatic products that are going to be required to do that, what kind of work directly with Solve on selecting those products and starting to integrate them into a system. So we do the sizing file, and an important piece to note here is you always start backwards. So start with the Z-axis, piece that's moving up and down, and now that moment load is going to be have to be accounted for on the y-axis, and then that y-axis is going to influence what happens on the x-axis. So you're really walking your way backwards through the system as opposed to starting with the x-axis and moving back the other way. Solve can do a CAD model layout of that concept. You'll see a couple examples of that Luke will provide. And then we want to put that concept in front of the customer, make sure they buy off on that, and then we can actually refine that quote, refine that design, and move to a finished solution. So why would you partner with Solve and Tolomatic in this case, and or your local system integrator? Fast response, and Luke will show you how they do that, but Solve's been working with a number of our distributors as a third party. So it's the distributor working with Solve, working with Tolomatic to create these gantry solutions. Solve has a tremendous amount of expertise and experience in putting these systems together and can do it very quickly. So you've got a quick CAD model that you can show to your customer. They can be very flexible in how they configure our products and the different machining capability they have on transition plates. We really think this is one of the missing pieces and one of the struggles we've had with bringing more multi-axis and gantry type systems to market. And in this case, we're able to partner together with our distributor, with Solve, with Tolomatic to create a solution that works well. Many of our competitors here, 14 to 16 weeks to do something like this. Here we've done things in 7 to 8 weeks on a fairly customized and unique basis for that customer that includes all of those key pieces, transition plates, the cable tracks, trays, etc. So with that, I'm going to let Luke talk you through some of the key things that go into a successful multi-axis or gantry type design. He's going to talk to you about all the things you need to think through and make sure you and your customer are accounting for. So Luke, I'll turn it over to you.
Thank you, Andy. Appreciate it. So yeah, when we talk about, gantry, if you're not too familiar with it, it might get a little bit overwhelming in the beginning, but we're going to kind of go through, each individual elements and show that it's, at the end of the day, fairly simple, and you can break it down into, simple mechanical solutions. So, this, on the screen is a very, basic gantry, very small, 4x4 feet roughly, and you can see, a few, on top of the Tolomatic actuator that I'm sure you recognize, you'll see a few connecting elements, jack shafts, cable management and things of that nature. So we'll go through each and every one of those in separate slides. And Andy, if you can go down the second slide for me. So, the first thing about Gantry, it's multi-axis, right? So you're going to have multiple actuators. Actuators going to have to get connected to each other. There is probably a million different ways you can do that based on the type of actuator you're going to be using, the orientation in which you're going to be placing them. So, one of the beauty of this setup that we have here between, Tolomatic, Solve, and yourself is that we're not locked down into a cookie cutter type of situation. It's fully customizable. You find what the need is. We come up with the right combination of actuators and the right way of, configuring them together so that it works best for the application. On the screen here, you see 4 different examples. It's pretty straightforward and self-explanatory when you look at it. But when we talk about, transition plates, it's a broad, term that encompass different things, obviously. So you see, it could be a simple plate. It could be, somewhat of a right angle configuration with, a couple plates and a gusset, a different way of configuring those transition components. Based on the level of precision of the system, you may have different features to those transition plates. They might involve dowel pins and alignment, precise elements. So that's kind of what you see on the bottom photo here. The one in the middle here shows right angle configuration, where you have actually a combination of plates that create the transition between the actuators. So I think that's pretty self-explanatory. The photo, take 1,000 words. So we could probably move on to the next slide, Andy. Thank you. So, sometime as you configure your gantry, you're going to find out that the type of load that you need to handle cannot just be handled by an actuator alone. Sometimes you're going to need some extra support to guarantee that the system can take your load and cycle. We can basically imagine any configuration that would have an outrigger or an auxiliary rail that would help us support that load. So there is various ways to look at it. You see a few examples here on the screen. One of them is B3W series actuator, to which we've added some additional support to make it stronger in taking side loads, especially in that case. You see a couple more examples here, which are we've got some B3S and we've got some MXB series that MXB series that are complemented with a standard linear rail that would allow us to take load over a wider range of travel. So again, very, very customizable. It fits the application. Whatever is required can most likely be implemented. So next slide here, cable management. Obviously when we're talking gantry, we're moving something. Very, very likely this something is going to be powered either electrically or pneumatically. So you are going to need to manage harnesses, cables, and all that good stuff. Just like the same philosophy applies to that as to everything else we just talked about. It's customized. There's not really one size fits all for that. So based on the application, we'll come up with the optimal configuration of cable management. We'll take into account things like bending radiuses based on the type of harnesses and cables that you're going to handle in there. We'll take consideration of the size of that e-chain cable management, same thing, based on how much, harness, how much cable you're going to get through that. And we can configure that for, multi-axis, X, Y, Z, horizontal or vertical. And there is not, this on the screen here, you see a linear version of it. We have obviously the whole range of cable management available to us. Moving on. to the next slide. Thank you. So, we talked about, auxiliary rail earlier. So, we kind of implied that, we would have a single actuator and a rail. But sometimes when the load is spread apart a lot, you are not going to be able to get away with a single actuator and an auxiliary rail. You're going to want to have two actuators working in sync with each other. So instead of simply, motorizing them with two separate motors, you're probably going to want to look at what we call a jack shafted configuration. So you have a single motor driving a master actuator, and it's connected to a second actuator through a jack shaft, and they are basically driven synchronously together. So on your screen here, you see a couple examples. One of them on the left here is very spread apart. So we're looking at a really long jack shaft with in-between supports that are going to guarantee that, we are not going to, wobble, vibrate, or whatever. And on the right side here, slightly less spread apart configuration, so we might not need all the support that we have earlier. Whenever we work with jack shaft, we of course size them according to the application. So it's based on the speed and accelerations that you are going to be working at, and this type of duty cycle. So jack shaft are sized accordingly. Okay, can go on to the next slide. So I talked earlier about, what are you moving with a XYZ with a gantry? You're moving usually a tooling, right? So end of tooling design is sometimes something that your customer may want to be looking at as well, and they might not have the expertise to do that themselves. So that is something that we can help with as well, whether it's using, Tolomatic products or complementing it with some of your products, grippers and other sort of, end of tooling. And we can also, look at fully customized solutions. So here on the screen, you see a couple examples. I start with the one on the right because it's the most straightforward. It's just a pneumatic gripper. So you can see here, we took a Tolomatic, rod style pneumatic actuator, and we attached a standard gripper to it, and it, this was a machine that would grab little metal rings. So just needed some sort of apparatus to do so. So this would be, just a configuration of standard commercial components, maybe with the exception of the gripper's fingers that are designed specifically for the application. And then on the left, another a different application. This is a completely custom end of tooling, which is basically a low profile turntable that was designed for an opportunity. So it just goes to say that you're not locked into a box, and you can offer pretty much anything that that comes to your mind, and we can work with your customer to implement the solution accordingly. So we are moving on. All right, so what is the process? How does it work from the time you get an opportunity and your customer will most likely ask you to provide a concept and a quote. It's very straightforward, and we'll help you throughout that process. We have no problem talking with your customer, getting involved at that level. We'll first start with a concept. So what you see on the top left here is typically the level of detail that you would get, let's say a couple days after you've brought up the opportunity, the application to us, and we, kind of gather the details of different parameters that Andy was talking about earlier. And you would get, a concept. I like to call it sometimes a pretty picture. It's not a full-on design, but it's something that is very representative, and that's going to help everybody, understand what we are offering here. So from a concept, and accompanying that concept, you will obviously get a quote and everything that comes with it, lead time and so on. When this transforms into an order, there's a simple steps that are being followed. Then we will go down to the bottom left picture here, which is a slight design refinement of that concept. So we will put together a slightly more advanced model, present it to yourself and to your customer, and there will be a back and forth communication. Is this what you're looking for? Does this fit within your dimensional constraints? And so on. So we'll refine the design and kind of just nail down a configuration that makes sense for the application. And that's what you will end up with on the bottom right corner. So after this back and forth communication, we nail down a design. Your customer and yourself will get a full-on 3D model that would show all the different parameters, and they'll be able to take that, drop it into their layout, or whatever they want to do with it. And you can see then once we've passed this step of design and we move on to manufacturing, what I like a lot about this photo is you can see that the final product looks just exactly like the model. So, and this is really one of the things we like to do is be very accurate with what we are going to actually eventually build, right? This way there is no surprises. So you could see that even things like cable management and how the wires are going to go through the system, every single element of this design is represented, and again, no surprises. Move on to the next slide. So that was an example earlier of a small multi-axis system, right? So we're not we don't have to stay small. Here is an example of a very, very large system that we've done. It's about 100 feet linear travel in one direction, and about 8 feet across, and another 8 feet vertical. It's an extremely large system with about 1,200 pounds of payload on it, and moving at speed as 5 feet per second of linear speed at max speed. So really heavy, really large. Again, the same process. You can see the conceptual phase. You can see that some details are missing out. We move on to a design phase, which is starting to look more robust. And then, one step forward, we got the design refinements, and finally the build, which is going to look very, very close again to the model. All right, moving on. Oh, so this is a quick video of that system in action. I'm not going to talk during it. All right, so we I think the video is pretty self-explanatory, but something you probably noticed is the it's a rack and pinion type of application, and that's something that is somewhat interesting as well. We talked about complementing designs and gantries with your own product line, right? So this is a typical example. In one of these axes needed more speed and more payload than a traditional actuator could handle. So we were able to complement that with rack and pinion componentry. So that's one thing interesting about this application. We can move on to the next one. All right, so that's another example, fairly recent. What you see here, you have two telematic products on that machine you might recognize. One is an MX actuator, belt drive, non-guided, and that's the one across, the long one. And then the vertical actuator is a RSA series rod style actuator, screw style. And you can see here, both of those actuators were complemented with linear rails to, absorb the type of load that the system was required to handle. This is a wheel testing fixture. So basically, this customer needed a reliable way to apply a vertical load onto a wheel and to cycle it rolling onto the floor back and forth for thousands and thousands of cycles. So, fairly heavy payload. Those were big wheels. Needed to apply a large amount of vertical force on. So we needed a system that was not only able to take up that load, but also to, handle many cycles without interruption. So you can see here the same mindset in the process. We start with a concept that looks, close, but not quite as detailed as the final thing. We move on to a design phase, refinement phase. To finally get the final product, which again looks very, very similar to what you will see in the model. And there's another video after that. I'll let you appreciate it.
Sounds good. I need it ready to ship by Friday. All right, we'll get it done.
Whoop.
Great. So something you probably noticed looking at this video, and it's interesting, and we'll touch to that in a little bit here. This gantry isn't just a mechanical system. It had motors, an electrical system that was provided with it. All these are options that we can explore and that we can work with you on. We can go as far as providing, a full-on turnkey solution, and we could do as little as providing a transition plate between two actuators. And that is kind of the strength of this configuration, this relationship that we have is that the type of service that we could bring to you guys is not. We're not locking you into a box. You tell us what you need, and we'll fill this gap between what your customer needs and what you are capable of providing, right? Before I move on to more turnkey type of system, I have a few examples I wanted to share with you. We just have on the screen here a few more simple configurations of gantry system. On the left side here is a small demo unit we had put together for telematics for a show. You can see it's a couple B3Ws, jack shafted for the x-axis or the bottom axis, another B3W across for the y-axis, and then a small stroke RSA actuator. All this driven by telematic stepper line. On the
Servo
right
motor.
side here, I'm sorry, yep. On the right side here, a few more examples of configuration, and you see, what I like about these three examples is that they can show how simple you could get. For example, the one on the bottom left of those three pictures here. And then you could get a step further with, what we like to think of kind of the standard configuration, two jack shafted for the x-axis, one single actuator across for the y-axis, and then usually a type of rod style actuator vertical for the z-axis. And then the one on the right side is kind of fun looking and interesting, but it just kind of goes to show you that it's not, there's always a way to be creative and to tackle, applications that are just non-standard in an interesting and an innovative way in some form and shape. So this one on the right here is two B3Ws, actually B3S series actuators, and we created some sort of supporting frame because you could see how long and how overhanging that vertical B3W is here. So it needed some extra support to handle the type of load and cycle and speed that it was running at. So the next slide, a few more examples. On the left here is another semi-standard configuration. It's a bit of a slightly more rigid and precise application. So here we use the MX series actuator for that. Each and every one of those transition is guided by dual pins, so you have a very good alignment of the actuator between each other. So it's dual pin, it's reference surfaces, it's whatever we need to do to make it easy to assemble and to align. Something a little bit different on that application is there's actually a fourth axis, not necessarily easy to see, but if you look at the bottom of the Z-axis, of the vertical axis, you can see a fourth actuator, so they needed a fourth degree of motion to make some fine adjustments. It was a camera system, a very precise camera system. And then a few more on the right here, just kind of giving you guys a little bit of ideas of how you can configure those different actuators to work on the application. So one that's kind of interesting is the one on the in the center here, the one in the middle here at the bottom is a slightly different version of a jack-shafted configuration. It had two right-angle gearbox connecting into a T gearbox. You can see you don't have to necessarily mount the motor on the one actuator. You could mount it in the middle or create mechanical connection and gearings to achieve that.
Luke, I also like the one on the far right where you're actually connecting the carriage to the actuator here. Now the entire actuator moves.
Correct.
So you can use this actually.
Right, that's a good point. So yeah, we call that a walking beam application. So it is like Andy said, instead of connecting the vertical actuator to the moving plate of the horizontal actuator, we connected two carriages together, which means that you almost use a rodless actuator as a rod style actuator in some way. So you have a walking beam that is moving up and down rather than a beam that is protruding downward and could be a problem if you have clearance issues, if you need to get into something. You might want to think of a walking beam type of configuration.
Great.
And then, so like I kind of touched 2 minutes ago, we could go further into this process, and we can, provide more than just a mechanical system. We could go as far as providing, full-on turnkey solutions. And these are some examples of the project we've worked on. On the left side here is a handling gantry system that would take sheets of metal and move them from a conveyor to, move them from a ball transfer table to a conveyor. So what's interesting about that system is you could see that large welded steel frame, the blue frame here. So we've created that frame around the mechanics to support it. And then you have a couple jack-shafted actuators, and across this is a y-axis bridge that is also supported through a frame. So we created a frame between the two jack-shafted X actuator to support the y-axis, and on this y-axis we mounted a turntable that is actuated up and down by a GSA rod actuator. And then at the end of all that is the end of tooling out, a bunch of suction cups that are going to come in and grab onto those sheets of metal and move them from the bolt transfer table, turn them 90 degrees and drop them onto a conveyor. So you can see there's quite a bit involved here, and this is something that can be offered to one of your customers as a full-on turnkey solution. And on the right side, somewhat similar actuation of conveyor transfer of product, but slightly more sensitive in the sense that we were moving glasses and not sheets of metal, so glass material. But the concept is the same. You have an heavy-duty steel frame with two jack-shafted actuator, and then a Y actuator across, a GSA moving the load up and down, and then some sort of pneumatic vacuuming system to grab onto those glasses and move them from a conveyor to another conveyor that runs 90 degrees from the first one. So just, some example of turnkey system, and there's a couple more on the next slide. Here on the left is a concept for a paint booth for buses. So the idea behind that concept was to use two rodless actuator. I believe there would be 3 Ws, if I remember right. These 3 Ws mounted on a rigid column, on 2 rigid columns, I should say, both moving on a linear track system. So linear overhead track system, and kind of just making its way around the bus and through some somewhat ingenious design of moving the paint sprayer around, you'll be able to get into the different crevices and different corners of that bus to coat it with a layer of paint. And then another one is here on the right side. Is a very large, I believe it was about 60 feet long V3W series actuator, jack shafted across with a heavy duty bridge, basically moving a set of large rollers across this is a very thick fabric, about 5 to 6 inches fabric. And then we would have a tool, which would be a saw of some sort that would cut across this fabric. So you can see the range of problems and application we can cover is pretty broad, right? And so with Gantry's, there's a few more things that we wanted to cover during their presentation. We could also help on things like billows, right? So if you come across an application with an environment that is, difficult, and an actuator on its own, it's just not going to cut it, and you need some higher level of protection, we can help you guys come up with, billow system for rodless and rod actuator. So this is 2 examples. I believe the one on the left side here is a B3S wraparound carriage actuator, to which we've attached, standard rectangular billow to it. And on the right side is rod actuator, GSA, RSA, I'm sorry, not GSA, RSA actuator with a standard billow attached to the rod. So these are, we can provide the billow themselves, and obviously all the right plates and fittings to adapt it to the actuator. Another interesting thing, and we've come across quite a few of those, is sometimes you have a customer who has a machine, an old machine, or an old design that they're trying to build a new machine of that old design, right? So that design might have an actuator from one of our competitors in there, and how do we get in and say we can provide you an actuator that's going to do everything that the old actuator was doing, but more, and on top of that, you're going to be able to take it and just bolt it right in place of what you had, and it's not going to be, you're not going to need to change your design and so on. So, we call those retrofits, obviously. And these are the type of things we can do. We can provide, custom mounting brackets, custom adapter plates, or whatever is required to take a Tolomatic actuator and retrofit it into an existing machine or an existing design. So this is an example here of an actuator. We've created, right angle mounts for a B3S series actuator, and then we've created a transition plate that would basically mimicate the whole pattern of the earlier actuator, so that whatever goes on top of this can just be directly bolted to it as if it was the same actuator. And then we've created a somewhat of a custom motor mount that the good thing about that is that it fits into the constraints of the design. So the design was such that we couldn't get away with a standard Tolomatic motor mount, so we put that together so that the design doesn't need to change already. So that's one example. There's a couple more here. So that's an interesting one. The thought process is the same. We had an actuator, rod stat actuator in there that we wanted to retrofit with an RSA actuator. So there was two things that needed to change: is the mounting flange for that actuator. So we created a custom mounting flange, that had the same hole pattern of the existing actuator, but bolted on to the RSA Tolomatic actuator. And then the other things that we needed to adapt was the rod end of that actuator needed to match the thread and the size of what was designing early on. So that's why there is this extension, this rod extension for the RSA here. And then another last slide here, similar mindset, I guess, as the first retrofit we looked at. The carriage needed to be adapted to be more of a, 80-20 style extrusion where you can, put in T-nuts and so on. So we built somewhat of a custom carriage that went right on top of a pneumatic Tolo actuator, and matched and mimicked whatever the earlier actuator was. So just another example. All right, moving on. So just to kind of summarize everything we just talked about, this is a flyer that we have, shows, the pretty much just goes over everything we just talked about: transition plates, support frame, end of tooling, jack shaft, special axis design. So these are the, the rotation or different things that are not necessarily, obvious, cable management, gearbox, motor drive, and then, all the way down to the full turnkey solution. So just kind of summarizing all those different points. So, why solve, and why do we think we have, why would you like to work with us, right? So what Andy was saying earlier is we can put concepts and quote together for you guys very quick. Typically a couple days, depending on the application, could be up to a week if it's very complex. But you can expect a rapid answer, and I think it's important. We've had instances where our competitor was just so much further out in terms of response that we would get an order before they get a chance to place to show their show a quote. So rapid response, competitive quote, tailored service. What I mean by that is you all have different level of capacity. Some of you guys may be able to fabricate, some of you guys may be able to design. We're not forcing you into a level of service. We're just saying, look, we're here to fill a gap. If you need help to manufacture, we can take on only that part. If you need help to design, we can take on only that part. And so the level of relationship is completely custom tailored to your need. Obviously, we will assist you in the selling process. we will, we have no problem talking directly with your customer and so on. So, and again, just kind of this slide just kind of summarize, the different things we could do for you guys, and you'll find our contact info, email address, website, and phone number. All right. Yeah, so that's, here you go, pretty much it. Then we can move on to the next slide.
I'm on mute. I'm sorry. Luke, how do you bill for design work was one of the questions that was asked.
Oh, so it really depends on the type of, on the project. So when there is a build associated to design, because we do all that in-house, we have the ability to pretty much absorb that cost and make it up in the build. If it's only design and there is no build, we would typically charge a fixed fee. So we don't really like to work hourly because we don't think it works for any party. So we would just give you guys a price up front. This is how much the design is going to cost based on what we've been provided, and that would not change.
Great. Okay. And just finishing up, we had 3 or 4 examples at the end. In the interest of time, we're kind of running long here. I'm going to skip through these pretty quickly. We've talked a little bit here. We've got X prime. You've got a Y. You've got a jack shaft. You've got your your GSA, so a guided RSA here. So XYZ configuration, stroke configurable. This could be, of course, any length or width, really. And one of the ones we're not going to show you, but was for a X-ray machine. They put a large part in a tank. Then they had these X and X prime that were 40 feet long, and then they had a Y and Y prime, actually, and then they had a Z that would move a camera around this tank, and it was 40 feet in length and about 10 feet across. So some really large systems that would have a common design element to these. Here's another example that we've talked through. You've seen the photo here, 3D printing and a spray booth. Very small, kind of tight design, but very capable from a load standpoint, reliability. Use that jack shaft design again. Here's a larger system design. We actually used our SRG, our right angle gearboxes, to create the jack shaft here between these two. This system is actually moving up, and then it actuates in from the side. So you got your X and your X prime here. They move up, actuate in, they grab this top tote, lift it up. The bottom tote moves out, and then they set this other tote down. So it's a stacking and a destacking of large totes. Actually, it was a plastic parts assembly. So the tote stacking and destacking, they had 84 systems. So this became a $300,000 solution for the customer. Used MXEs, our largest MXE 63s with a screw drive here in order to be able to support that load. And they didn't have to move very fast. So a very solid design. Here's another system where we replaced a rack and pinion system. They're having a lot of challenges in the assembly process, manufacturing, where they had to really have the rack and pinion very straight and smooth and completely lined up. So it's taking a lot of time. We were able to essentially drop a B3W on top here to create the X axes, and then we've got the Y axes as well here. So you've got or called it a YZ, I guess, but you got a B3W across the top and then a B3S. It's taking parts and moving them from one dip tank, one chemical dip tank to the next throughout their process. So 22 feet long. So we used our B3Ws with a splice kit. That's a semi-standard option. It's configurable and modified standard. We'll talk about that on Thursday, so that's just a little preview. But really gave them a lot of control over their load, their speed. It was very easy to assemble, and this has become their standard design now going forward. They estimated about a 25% cost savings, and a lot of that was just in labor, et cetera. So, and here's a large design system here. You've got a couple axes of motion, and this was doing inspection of, I believe, airplane wings, so X-ray inspection. Luke, I don't know if you want to add any more color commentary on that.
Yeah, no, that's pretty much what you just said. It's a airplane wing inspection system, X-ray inspection system. So you would have an X-ray generator and an X-ray detector moving in sync with each other and facing each other out and kind of looking at this wing in various angles. So that's actually a 7-axis system, 5-axis in the gantry and 2-axis in the wing holder.
Great.
And so B3000 is in